Thank you everyone for joining the Vulkanized webinar focused on the Vulkan 1.3 software development kit. During the webinar, we will hear from LunarG's SDK experts who will provide training on the Vulkan 1.3 SDK. First, a couple of housekeeping items. If you have any questions during the presentation, please ask them using the Q&A feature located on your Zoom toolbar at the bottom of your screen. We are recording this session and will share the link when it is available. At the end, please complete the short survey form to help us better design future events. In today's session, we'll hear from Jeremy Gebben, who will talk about validation layer performance. Following Jeremy, we'll hear from Christoph Riccio, who will give us a tutorial on the Vulkan Profiles toolset. After each presentation, there'll be a Q&A session. With that, let's get the webinar started with Jeremy Gebben from LunarG. Jeremy?
Hi, everyone. Can you hear me okay?
Sounds good.
Yeah. So my name is Jeremy Gebben, a graphics and software engineer at LunarG. Been working on a combination of graphics drivers and other device drivers for the last 25 years. I've been at LunarG for about a year and a half now. So today we're going to be talking about what I've been doing for probably the last 6 months, which is optimizing the locking in the Vulkan validation layer. And this is to improve performance of validation when running multi-threaded applications. So we'll go through the effect of the optimization, how you can enable it, some details in the code about what it does and where it's at and what's going to happen next. So to start out with, here's the lock contention in a very highly multi-threaded Vulkan game. It has about 16 threads that are using Vulkan pretty much continuously. And it's kind of my worst enemy for performance in terms of how the validation layer does running it. But without validation, it's about 3 milliseconds per frame, and it's several hundred frames per second. When you turn on validation, the performance craters, basically. We go to 393 milliseconds per frame. That's just over 2 frames per second. And looking at the lock contention, you'll see that there's a large amount of time spent waiting on these two methods inside the validation layer for these global or device and instance level read-write locks. And that's a big chunk of what makes validation so slow with this game. So with the new feature enabled with the locking re-architected, we get quite a bit of performance back, 191 milliseconds. The lock contention from the validation layer goes way down from a couple hundred seconds in this little snapshot of time to about 15 seconds. And frame rate goes up for many shipping games by about 150%. So a lot of games go from where they're barely usable to where they're somewhat reasonable. And a big part of this is that the validation locks are now guarding a smaller section of code, and more often than not, these 16 threads can run in parallel. So to enable this feature, you can use the Vulkan configurator. There's a new option called fine-grained locking. It's marked as beta because this feature is its first release and we are still trying to prove it out. It's off by default, so you can enable it with the Vulkan configurator. There's also environment variables, and in the VK settings, there's a configuration option. An important point is this: right now, this only affects core validation, and we'll get into some of the details of the code about why that is. So what happens inside the validation layer for a Vulkan API call is these 3 loops. So the loops are over what are called validation objects in the code, and those refer to different areas of validation. So core validation is represented by a validation object. So is sync validation and all the other areas. So we'll run through all of those active validation objects and lock their read lock, call their read lock method, and then call the pre-call validate hook. And then after that, call the pre-call record hook with a write lock held. Then we'll call down into the driver. And then after that, we'll do a post-call record hook. So not every Vulkan call implements all of these hooks, and some of them are more expensive or less expensive than others. But in general, there's a lot of code inside of each of those hook methods. And the way this method works is they return a lock guard for this mutex at the device or instance level, and the fine grained locking feature changes that to use this feature, this part of the SDL called the defer lock policy, which means there's a lock guard that is not actually locked to the mutex. And then the idea is that other parts of the code have separate locks that only protect a small section of a small critical section, and those make the validation layer thread safe, even though this lock is effectively removed. And the reason it's done this way is so that we can have the ability to turn this feature off and on. So both so that it's kind of an opt-in feature right now, so people only get the new behavior if they want to try it, and then later we'll have it as an opt-out feature where if we think there's a problem with an application because of multi-threaded, we can say, hey, turn this fine grained locking off, and we'll see if the problem goes away, and that'll be a good debugging step for both for us and for people using the layer. So as I mentioned, the validation objects correspond to all of these different validation areas that are exposed through Vulkan Configurator. Right now, only the core validation has changed for the SDK. Thread safety, object lifetime, and stateless have always used this deferred lock mechanism. They've always had their own locking, so they're a little bit more multi-thread friendly already. And then in a future SDK, we'll expand this to cover the other validation areas. Best practice is GPU assisted debug printf and synchronization. And so I've gotten some questions talking with various people about both inside and outside LunarG, or why do we have locks in the validation layer at all? And I mean, the main reason is we can't assume that the application is correct. We have to validate all the handles that are coming in from the application, and we do that with these thread safe maps that look up the handle and ensure it's valid. An application could give us a garbage handle that was never initialized, or something that's already been destroyed. And the purpose of validation is to make it possible for applications to not have, and drivers to not have checks for that kind of thing. But I mean, it has to happen somewhere, so it happens with us. So we have these maps, and we also have a lot of state about each Vulkan object that we need to keep track of for validation. And so these state objects are C++ objects stored in these maps, and they're now reference counted using shared pointer. So you don't have to have the map locked while you're looking at a state object. You just have to have a shared pointer to it. And then additionally, sometimes we update these state objects when there's not an external synchronization requirement in Vulkan. Probably the best example of this is VK image layouts. The only places you have to have synchronization for them is when you're binding memory or destroying them, and maybe a few other calls. But they get these objects get used all over the place, and we have to do some very complex layout tracking for every sub resource. And so we need to have a lock on that so that the data structure doesn't get corrupted while validation is running. That said, we're still not trying to make it, so we're not trying to change how Vulkan works, so or at least explicitly. So our assumption is that applications should use thread safety validation to make sure that they're following Vulkan's guidelines for multi-threading. and our goals are that applications that don't have errors from thread safety validation won't crash. They'll produce the same set of errors when validation is run, both with and without fine gradient blocking. But the order of the errors can change from run to run, and this can be seen even in some of the CTS cases, the conformance cases that use multiple threads. The order will shift around just from run to run because of how the threads get scheduled. And we don't see that's not a problem that can really be fixed. And then for programs that have errors, we're going to try to fix crashes if they happen, but there's no guarantee of correct output. This is kind of been the policy for validation for a long time. Once you start getting errors, we don't really have a lot of ways to make sure that like the 101st error is correct, is a valid error if there's already been the previous 100 errors. And within the state object, we have developed a number of different policies to try and make this problem manageable. The first goal is that anything that can be immutable, where it's set up in the object constructor and never change, is a public data member, and it's marked const, so that both the compiler and the developers know that this never needs to be locked. If you have a valid reference to that state object, you can access that data without worrying about any locking. After that, there's places where we do have to change data, where we have caches or lookup tables or whatever, so we don't have to always query down into the driver to find out something. In a lot of cases, those can just be made fully encapsulated within the object, where there's accessors and private data members. And then after that, we get into some cases where we can encapsulate all the data accesses, but because these objects interact pretty closely, you have to be careful as a developer to make sure you're not holding multiple locks in a row or causing deadlock. And the best example of this is the queues, semaphores, and fences, where we're trying to use state changes in the semaphores and fences to determine how much forward progress has been made in the queue. And so we have to have callbacks into the queue that say that, oh, this semaphore fired, which means that the 5 previous command buffers have finished executing, stuff like that. So there's some care that has to be taken to make sure that's thread safe and not causing deadlock. And then finally, kind of the worst case is command buffer, where there's tons of state associated with it. There's pretty good external synchronization requirements for command buffers, but still we sometimes have to access this state when we don't have those sync requirements. And it's currently not feasible to restructure this so that everything is encapsulated without causing a huge performance impact or just massive code churn. And as a result, the caller, the validation object code that's using the command buffer is responsible for the locking. They have to make sure that they're holding the lock and release it at the appropriate times. There's some helper methods in the state tracker that I'm not going to go into, but to try to make this easy, but it's still already proven to be pretty fragile. And one of my goals right now is to try and make this part of the code better so that it's not as error prone. And I mean, that's the summary of where we're at. My next goals are to expand this to the rest of the validation areas, like I said, to improve this command buffer locking so that it's less likely to cause bugs. We're trying to add more tests and benchmarks to our internal CI so that we have high confidence that it works and that we're able to detect when performance changes. Then the part where y'all come in is we need feedback. If you have an application that's multi-threaded and has had performance problems, give this feature a try and let us know if you find any problems or areas where it's still slow. And we'll try to get those fixed. So once we have a little bit more complete implementation and kind of better coverage and feel that things are working well, we'll switch this to be default to on in a future release, and then we'll leave the ability to turn it off for debugging. So that's a summary, but that's it for my presentation. There's quite a bit more documentation. There's a usage guide in the validation layer documentation. There's also a design document that goes over a lot of the implementation details that I kind of just glanced on. That may not be interesting unless you're actually working on the validation layer, but it's there. And then the other link here is to the Intel vTune profiler, which has some really great visualization tools. That's what I used for a lot of the investigation into the performance while developing this feature. So I'm going to stop the presentation, and now we'll see if there's any questions. Looks like we got one. When is it better to leave fine grain locking disabled? Is it best to just try the application and see? Ideally, we're going to want to get to where this feature is always on. Like I said, right now it's off so that we don't randomly start crashing applications that expose bugs that we hadn't seen yet. So yes, right now, try it with your application, and hopefully it works, and then you get better performance and still get good validation. And if it doesn't work, like I said, file a GitHub issue, we'll get it fixed and try to lock down this feature. I don't think in the end that this will hurt performance for any applications. So I think we'll want to get to where it's only disabled when you're debugging a bug in either the validation layer code or your application. And something in chat. Nope. So
thanks, Jeremy. That was a really nice, straightforward tutorial. Next up is Christoph Rixio. Christoph will give us a tutorial on the Vulkan Profiles toolset. If you want to go ahead and grab the screen, Christoph.
Yes, thank you. So I'm joined with Giga, who was my partner in crime developing this project. So in the agenda, basically, we want to give a Vulkan developer, I would say, a larger perspective on how Vulkan profile could be useful for them. We are going to present the Vulkan profile toolset components because we have multiple different tools involved that we developed with Vulkan 1.3 release. And I'm going to explain how to use this tool at the same time. Everything is described in a white paper that we shipped already. So if you want more details, I strongly invite you to have a look. The presentation is going to be a little long, and but I'm not going to be able to cover everything because it was a lot of work and things that we did. So first, because I'm not sure exactly to who I'm speaking to, I was hoping to clarify my expectations so that people are not lost without with wrong expectation. So I'm expecting that you wrote some Vulkan code with yes, and that you know how to use Vulkan configurator to set up Vulkan layers. And also, I think you will be more interested in this presentation if you have some interest in writing portable Vulkan applications. And when I'm saying portable, it's really making sure that the application we develop is not working just on the developer system, but on the end user system. And I will say even the entire ecosystem of application, of a platform we want our application to work on. So first, I'm going to give some an overview of why we made the Vulkan profile toolset and what state of mind we had creating all these components. So really, for us, the Vulkan profile is a tool. I'm not sure if we should say exactly just a tool, but a solution to create a portable Vulkan application. In practice, of course, Vulkan is a portable API, but there is so many Vulkan capabilities that how do we resolve the problem of plugging applications and platform capabilities? This problem seems bigger and bigger as time progress. And really, in my perspective, Vulkan is not a low-level API, it's an explicit API. There is nothing that happens behind the user backs or the developer backs. And the Vulkan profile is a concept that is created in the same spirit of being explicit. So how are we becoming explicit about the capabilities that we require for application and that the platform provides us? So we could imagine that it would be nice that the ecosystem would become more homogeneous, but that will never happen because there is heterogeneity in the Vulkan ecosystem for very good reason, because a car is not the same as a phone, as a console. So what we hope we can solve with the Vulkan profile is, thanks to this data convention and the toolset we provide, to have some form of communication between the requirement on one side and the support on the other side, so that we can actually, when we write our Vulkan application, we can target a specific domain of device where we know it will work. And what we want to do is to be able to use Vulkan profile now and not waiting for Vulkan 1.3 to be adopted by a large part of the ecosystem. And for this, we made, with the support of the Khronos group, some strong decision, like there is no Vulkan API for profile in the Vulkan API. It's part of the toolset. So I was speaking about considering profiles as something broader than just what was shipped at Vulkan 1.3 release. So of course there is the roadmap 22 profile that was released, and the purpose of that type of profile is to give some form of future direction for Vulkan devices. We had also, at the same time, at Vulkan 1.3 release, we had a platform profile, which was the Android 2021 profile, which gives a perspective on a large amount of devices that support a set of features on Android. But on the case of platform profiles, we could imagine so many things. And for example, with LunarG, with the Android profile, with the Vulkan SDK, we shipped what we call a portability, a desktop portability profile that allows to create a Vulkan application that will run on Linux, Mac, and Windows, which means if we follow this if an application follows this profile, it will not use any feature that are not supported on this platform on a broad range of devices. Then we can imagine something like device profiles. And device profiles is basically expressing the Vulkan capabilities of a driver, or a specific version of a driver and a device. And this is basically what we found on gpuinfo.org. We could imagine also something very similar that they called an architecture profile, and that will be expressing the capabilities, but for a class of GPU. And we could imagine other things like what I would call engine profiles. So we could imagine that an engine, a graphics engine, could have multiple rendering code paths. And if we want to leverage this rendering code path, then the platform where the code path should run should support the profile of this engine, which means it kind of communicates to the platform owner or the IHVs what Vulkan capabilities needs to be implemented in the driver, in the hardware, maybe, so that this kind of rendering code path exists. And there could be many usage. And I hope we don't know all the usage, and I hope that you will be creating a usage for the profile where typically it's always solving some form of communication problem between different members of the Vulkan community. So here is an example for a platform profile. So we could imagine that the platform owner specify a platform profile, and that will have implication for the Vulkan driver, and there will be it will provide some guarantees for the application on what feature can be used on this platform. And here is some sort of what I described with engine profiles. So we could imagine there would be high quality profiles and high performance profiles. So of course, it's all very arbitrary, but we just need to, that's the sort of things we can do. So now I'm going to quickly do an overview of the component, and then after the overview of each component, I will describe each of them with more details. So the first component, as I was saying, a Vulkan profile is basically just a convention for storing some data as far as we are concerned in the SDK. So for this, we need a schema, and this is a JSON schema. So it says how to write a JSON file so that it could be interpreted by tools. So yes, I forgot to say that everything in our solution is require Vulkan 1.0 and a get physical property 2. So there is no need for Vulkan 1.1, 1.2, 1.3. It all works, and you will understand why in few seconds. Currently, we are still shipping as a beta development stage, which means that, for example, the profile schema could change in format in a way that it will not be backward compatible. So the Vulkan profile schema, it basically stores extension, feature, property, formats, property queues. So we, for every release of Vulkan header, we generate a new Vulkan profile schema, so that if there is a new extension, the extension will be added to the new version of the schema. We have a comparison table, so it's basically a markdown representation of profiles, which allows to compare different profiles. So I can give you, I can jump here to give you an idea of what it looks like. So if we look at the Vulkan SDK, there is some profiles, and we see the API requirement, for example. We see the extensions for every what's available or not available, or part of core, or which part of core versions. And if we go even further, what we can see is that we have a tooltip. So maybe the tooltip is very small for you, but you will even see when a feature is supported using what structure. So the schema doesn't only describe the feature that are available, the capabilities that are available, but also how to use it. So what API to use. Oops, I went. So we also have a Vulkan profile layer, which, if you are familiar with it, replaces the DevSim layer, but it's way more powerful. So basically what it does, it downgrades the Vulkan developer system capabilities with whatever the profiles specify. So it means maybe we expect actually that application developer will have very advanced GPUs. But what we can do, it's to say, oh no, don't report you support this extension. Don't report that you support this feature, this property. This is what the layer is doing. I will go back into more details on how it does it. And it also allows to do additional checking for the profile definition, and I will also explain what this additional validation it could do compared to the schema. And finally, the last component is a library. So as I was saying, there is no Vulkan API for profile in the specification. It's part of a library. The library is designed to be very easy to integrate, and that's why it's a header-only C++ library that we can just copy paste or include from the SDK. And basically what it allows to do is to check in the Vulkan application if a profile is supported, and to create a Vulkan device with all the feature and all the extension from these profiles already enabled. So it could be seen as a helper library. Once again, I will go into more details of how to use this library later, but I won't be in too many details. So here is a drawing to show the deployment on the developer machine of the different toolset components. So the Vulkan profile API is not part of the Vulkan API because it will mean it will be part of the driver. It will be delivered with the driver. So if we would like to use this API, we will need to update the driver, which is very complicated on some platform, such as Android. But even on desktop, it's absolutely not the same as having it included into the application, because we just need to update the application to leverage the profile API. The layers, they are used during development time, and the profile layer typically works together with the validation layer because all the profile layer is doing is downgrading the capability reported by the driver on the system. For this, it uses the Vulkan profile file, but these values, they will be checked against the validation layer that will notice how you are using a feature you're not supposed to use. So it's really the validation layer that will report errors. Of course, the layer, they are loaded by the Vulkan loader and configured by the Vulkan configurator. So one thing I didn't discuss is that, yes, the Vulkan profile files are JSON files, but shipping a JSON file would be very annoying for many applications. And that's why the profile library, the profile library is just a header which implements the JSON files, and I will explain at the end how it's done because it's pretty powerful, and we can do really expand the usage of profile thanks to our design, I hope. So first, the schema. So the way the file is described, as I was saying, it represents the capabilities, but there is a part which lists the Vulkan capabilities, and then there is another part which actually specify the Vulkan profile themselves. And these two things are separated for one good reason. It's the Vulkan profiles in the JSON file reference capability set, but it doesn't have to reference all the same, all the capability set. So what we can do is to express multiple variants of one profile inside of a profile file, or actually we could even express a profile that has nothing to do together in the same file. I'm not sure if it's a good idea, but we could. So we could imagine, for example, with Angle, if one day we have an Angle profile, they have multiple code paths where they can implement inside Angle some feature using some capabilities, but they can also implement the same feature inside Angle using other Vulkan capabilities. So for that, there would be two different variants of the same profile. So basically, we can factorize the capabilities that are in common into a capability set. And then for the variation between profile, we can add a different capability set that we reference independently in each Vulkan profile. Another example is there is extensions that are platform specific. For example, the portability subset extension, which allows to use Vulkan on Mac. It's great. It does exactly that, allowing to use Vulkan on Mac. but it's an extension that must be there on Mac, and that's an extension that must not be there on Linux or Windows. So in that case, we need two variants to express these two different things. So the profile, as I was saying before, express the capabilities and how to use the capabilities. So in each of these structure, there would be a physical device descriptor indexing feature ext, the core one, and the bundle Vulkan 1.21. There will be some capability express. So if we include in a profile file the capabilities, it will reference also which structure that could be used. So we could say, oh, who cares? But actually, it's very important because a profile is not just enabled, it's also implemented. So if an application starts to use a core feature, but actually the platform only has the extension, that will not work and it will actually crash. So yes, once again, there will be a Vulkan, a new schema for every Vulkan header revision. So here is just a file, an example of the structure of a profile of a file. So on top there is a reference to a specific schema, and we have the two parts I was saying. First is the capabilities, and then there is a profile. So in this this file just shows the structure of what can be done, but I'm not going to show everything because it will be a very big file. But one thing we can see is that, for example, there is a set. So there is two capability set. There is one that is called baseline and one that is called unused. And it's called unused because it's never referenced in any of the profile listed. So here there is only one profile, and it only references the baseline. So it's very convenient as well when we implement a new feature. Maybe we want to be able to quickly add or remove a capability set, and we don't have to remove from the file all the feature property and format and extension. We just need to not reference that capability set, which is more convenient. So where can we find some Vulkan profiles? We can find them in the Vulkan SDK package. We can find them on the Vulkan profile repository. So that will be the more or less official profile. So it includes the Khronos 2022 profile, roadmap 2022 profile, the Android 2021 profile, and our LunarG desktop portability profile. But if we want more profile, we could gather some profile on vulkaninfo.org. So I'm going to show you. GPU info. So on GPU info, I hope everyone knows this website because it's really great. So when we reach the page for Vulkan, we can just open a profile, a report, and look at the report. So there is this person who submitted this file today, and we see now we worked with Sasha Willem who do this amazing website so that it can export the report in a form of a JSON profile. So, click. Okay. So let's go back to the presentation. So I would like to discuss very quickly on the Vulkan schema versioning. So each file has the same sort of each schema file has the same sort of convention, which is it's called profiles, and then there is a profile schema version, and then there is a header, a Vulkan header version. So currently we call it 0.8 because it's beta, and when it will be stable, we will call it 1.0. But we don't know yet when this will happen. If you are only interested in using the latest header schema, you can just use the latest, and you will have all the extension available. But there is some good reason to use a specific version, and I will explain why right after. So where to find these schemas? It's also available in the SDK package. In the SDK package, it will always be the latest Vulkan schema, a Vulkan profile schema with that implement the Vulkan header version shipping with the SDK. You can also go onto the Khronos schema website, and actually we should probably have a look. And what we see is that there is plenty of schema version. We created or we generated actually the schemas down to 96, so Vulkan header 96. And the latest header that was released this week is already on the website. You can also go into the Vulkan schema repository. This repository is very new, and it's basically the backend for the Khronos schema website. It could be convenient to use the repository if you are interested into fetching all the schema version automatically in a project. And also, but there will be only the latest JSON version. You can have a look at the Khronos profile repository, where all the Vulkan profile components are present. So all the work is done into this Vulkan profile repository. So I would like to make a small demo. So what does it look like, and how to validate JSON files, and what's validated. So if I'm going there, what do we have? So I'm going to take the latest oh, yes. So I just copied the roadmap 2022 profile, but here I'm using a 197 schema. And what that does is that it detects that some of the features that are listed into the JSON file are not supported by this schema. So if we go down the file, we'll see the definition of the roadmap 2022 profile, and we will see that the API version, the required API version, is 204. So I'm going to pass a more recent file, and up, and now it's correct. And the version I copied, it's 204. So so the reason of having all these different schema version is precisely for this. It's so that we can never, when we set some requirement for a profile, we can never add a feature in a profile that will not be supported by the API version we require. So there is many other things that are checked. So for example, what could I do? For example, so if I mistype something, like let's call it A, it will detect that this is not, there is a spelling mistake. Even the case, it's case sensitive. He will detect if we use the wrong type. So for example, no, it's an integer. What could it do? It will even detect if we set a value that is smaller than the smallest value. So if I do, yes, the minimum is 0. So it's a pretty exhaustive checking of the file, but there is still some limitation. I'm going to go back to the presentation to show you some limitation. So we have a convention in the profile file definition that we can have multiple sets capability set that specifies the same structures. And when I say the same structure, it's the same structure that store capabilities. So for example, a physical device descriptor indexing features. And if we have multiple, if we reference multiple capability sets that define the same feature, the last one will override the other. However, inside of capability set, there is nothing that will, there is no validation that will not be done. But if we reference the runtime descriptor array, we set it to a capability inside VK physical device descriptor indexing feature ext, or the core version of that, or the Vulkan 1.2 version of that. And if we reference it with different value inside the same capability set, the profile file will be valid, but it's an undefined behavior. So we don't know which value should be taken out of these three values. But for that, we can use the profile layer that will report a message in such a case. Another issue, which is equally as important, is that, for example, Molten VK, which is the implementation of Vulkan on Mac, only supports Vulkan 1.1, but it still implements the 204 header. So it would be nice if we could say use Vulkan 1.1 and it will report error on if we use a feature that were introduced into core Vulkan 1.2 or core Vulkan 1.3. But actually we can't because the schema is generated out of vk.xml, and vk.xml is just written for the last version of Vulkan, not for everything. Well, this is something we are hoping maybe with some improvement to the schema that we could solve, but right now we are not quite sure we could fix it. But once again, it's something that the profile layer will report message if we have if the profile include a feature which doesn't match the API requirement inside the profile. And the last limitation is that there is some capabilities that we can't express in the Vulkan profile schema, and probably we should add them, such as memory types, surface capabilities, and maybe other, but we haven't really considered all of them. We were really hoping to add the memory types, for example, but we were not sure the right way of doing it, so we prefer to defer for another version. So next step, let's discuss about the Vulkan profile layer, and it will be very quick. So once again, just to remember, the profile layer is configured with the loader and the validation layer. And here I would like to remind that the profile layer is not a software implementation of Vulkan. It just downgrade the capabilities of our developer machine. There is only one extension that it actually implements, but it's a very trivial one, and it's the KHR portability subset extension. But the portability subset extension is just reporting the support of feature to the application. So it's basically what the profile layer is always doing. So there is a downside, is that if there is some features that are mobile specific, some extension, we can't emulate them on desktop because we can only downgrade on the capabilities. And here I would like to give some perspective on how could we use the profile layer to be more effective during our testing. So typically, if we consider testing an application, it's sort of iterative process between iterating with multiple devices. So basically, we run the application on a machine, we check that the test works, and then we test another device. But this process is very ineffective. Actually, it's infinitely long. We can't really test with a lot of different drivers, either because it will imply buying machine just to check on a specific driver version. So what we think Vulkan profile can do is to change the paradigm of testing that an application could run, because of course there could be a performance issue and driver bugs, but at least in terms of capabilities, what we want to do is not to test against devices, because that's infinitely long. It's an infinitely complex problem. That's too many devices, too many driver. What we want to test, it's against a profile. So if we manage to build a profile, and this profile capture all the capabilities that we want our application to depend on, and that we know that this profile, let's call it a platform profile, we know that this profile is built from all the devices we will typically learn, then it's a minimum, the profile captures the minimum set of features that is necessary for the application to run. So we can just run once. And I'm not saying it's the only thing we should do, and there is certainly more testing, but at least checking that the application works because it doesn't use a feature that it should not use, this should be a solved problem. And so I'm going to give some use case example. So I really think that one use case that should be mandatory for any application is that when we have a CI system, the CI system should, or at least one test should check that the application never add unintentionally some Vulkan capabilities requirement. And that's a very trivial to do. We just need to set up the Vulkan layer, the Vulkan profile layer with a profile that capture what platform we want to target, and be done. What we can do is to check that with the profile layer, we can check that the application will work on our platform with a less capable device than the Vulkan developer device. What we can do is, while we develop, we may add the support of a new extension, for example. And what we can check is that when we add this support with the profile layer, we can configure the profile layer to for example, report that this extension is not supported by the driver. So we can see that the application fallbacks correctly when the new extension we implemented is not available on the system. Yes. So with the Vulkan profile layer, we can check that the Vulkan profile is well formed, but that I already said it. So I'm just going to show you very quickly with Vulkan configurator how it's done. So I hope everyone is using Vulkan configurator because it has some very good advantages, such as you don't need to link your C++ code to check to enable validation, for example. So when you open Vulkan configurator, there is a configuration which is called portability. This configuration has two layers pre-configured, which is a validation layer and the profile layer in beta. And we can we have some preset with we have some preset yes there with the layer the profile that we ship in the Vulkan SDK. And all we need to do, because it's pre-configured, I want to check if VKCube, which is the application set there, can run correctly when the application supports the desktop portability preset. So let's do that. Yeah. If we want additional information, because we didn't have too much information here, basically we only had the validation layer saying I just got initialized. We can add some notification, and the notification for the profile layer we say some things such as the settings that were used to configure the profile layer. So we can see the profile file that is used, we can see the profile name that is used, and we can see some capabilities that are simulated. And for example, there is API version. So when we force to use, yes, basically what it does, it's forced to use the API version that is specified in the profile. So each different area of the profile can be individually set. Yes, that's it. Maybe I can show another thing. So as you can see, when we say simulate, it really replaces what the device will report. If we just load a profile, the profile layer will report this machine. If there is something on the machine that is specified by the profile that is not supported, it will say, oh, I don't support this extension, for example. But it's very different from overriding, for example, the format reported. So on the desktop portability profile, there is some formats that are not available everywhere. No, sorry. So if I use a simulate profile capability with format, then the capabilities of the format reported will be the one that are available everywhere. But I know that on my platform, there is some format that are available on my platform, but not on the profile. And this is going to report some error because Vulkan Cube is using one of these formats, two of these formats actually. And here we see there is a warning that says, of course, it runs because the format is actually supported and by the device, but the profile says doesn't include the D60 UNorm format. And this sort of limitation is really because of Mac. That's why it is. So let's go back to the presentation. So there is one big limitation with the profile layer, and this limitation is that we can't override Vulkan instance extensions. So if the profile include a Vulkan instance extension, then we can't change what the device will report, and this is due to a Vulkan loader behavior design choice. So let's discuss now about the Vulkan profile library. So the Vulkan profile library is part of the application. It allows to create, to check that Vulkan profiles are supported by the platform. It allows to create VK device instance with all the feature and extension that is specified by the profile, all this extension and feature enabled. So we could use profile and we could use the library to simplify the Vulkan initialization code in our Vulkan application. And we also have a bunch of API to do reflection on the Vulkan profiles. So this is to know in the C++ code what property, what format, what feature are specified in the Vulkan profile code. So how to include Vulkan profile in the application code? It's very easy, especially when the Vulkan SDK is installed. We just need to include Vulkan profile.hpp. But there is also another approach, which is by going to the repository and grabbing the files and copy pasting the files directly into the code base. The files only depend on vulkan.h So there is no extra library or anything. And there is two different flavors. There is one which is a header-only library, but the file is kind of big. And there is also a C header library, so that it could be used with other language binding and a C++ file. So having a dedicated CPP file allows to avoid increasing compilation times for maybe no good reason. So the file will be compiled only once instead of whatever is in the HPP. I would not recommend to include the HPP file everywhere. That will increase compilation time quite a bit. And if we want to use beta extensions, such as the portability subset extension, we need to enable enable beta extensions. Define VK enable beta extensions, just like we do with Vulkan.h. So it's very similar. And we don't even need to use, when we use Vulkan profiles .hpp, we don't even need to include Vulkan.h, but that's very important. So what the library, if we look at the library, what it would look like, we will see some define that says what are the list of profiles available in the library. For each profile, it would be the first KHR on map 2022 is just to say the profile exists. So we could have if def error if we use a new version of the library, but that doesn't include this profile. It specifies the version of the profile, and it specifies the minimum version, API version to use this profile. Okay. So the checking, so we have some API to check either at instance level or at physical device level if the profile is supported. We have the same two API at instance level and at device level to create instance that will, so here it's a Vulkan instance that will enable all the extension in the profile, all the instance extension in the profile that we pass. And we pass the profile within this VP. So all the Vulkan profiles are not VK, they are VP something. And we have a new structure which is called VP instance create info that encapsulate VK instance create info, plus has extra information such as the profile we want to create the instance for. And it's the same to create a VK device. And then we have plenty of reflection API to list the instance extension, to list the device extension of a profile, to list the structures types that are specified in the profile. This could be pretty useful. To query the feature set in the structure of a profile. And we can also, so one parameter is pnext, and you probably remember this pnext from VK create device that has a pnext as well. And if it's a pnext, it's because we can chain all the structure we want to fill. So in one call, we can fill all the structure at once. But we can also do it one structure at a time if it's more convenient. And we have the same sort of function for query family properties, for formats. And finally, we have two special functions to list a profile. there is one to list dynamically all the profiles available in the library. I don't really expect it will be very useful because we have the define, and implementing a profile in an engine is not just doing something dynamically, but it's really writing some code. So it's very much a static thing, but it could be useful. And there is a get a profile fallback. So I said earlier that inside a profile file, we can have multiple variants. So this allows to list for every profile in a profile file the list of fallback that could be used as an alternative to a profile. There will be, but it's not, there is a PR, there will be a Vulkan sample to use the profile library inside the Khronos Vulkan profile repository. And I would like to show you some code very quickly in Visual Studio. So I just opened the project, which is created from the Vulkan profiles repository in the Khronos group GitHub page. And if we look at, this file is just a unit test file, but I think it does, it shows very well how it works. So for example, in this test, we are creating a profile with a profile name, which is desktop portability, and the specification version for the desktop portability. So first we query using this function. So I remove all the instance creation. The VK instance creation is not done, but it's the same principle. It's done, but at a different place in the scaffolder part creation. But anyway, let's focus on this. So first, we check if the profile is supported at device level, and it will report it's supported on this machine. But then what we can do is we will decide, the desktop portability profile supports some feature, but I want more feature. This profile is very boring. What I really want to do is to use the subgroup size control, and maybe I want to be sure that a desktop, the robust buffer access is disabled because it makes my my applications slower on some driver. So what we can do is we create these structures, and then we call VK profile feature, and it will load all the capabilities of the profile inside this structure. Then we modify the structure from the profile with the new feature we want, and we pass these structures. Where do we pass them? We pass them here. Yes, it's chain from here into VK create info. We use this VK device create info instance into our VP device create info instance. We say which profile we want to use, and then we say override the feature I passed to override the profile with the change I made to these structures. So when we call VK create device, there will be all the capabilities of the profile plus the capabilities I changed in this piece of code that will be enabled into my device. I can, so there is some additional functionality in the library, such as the roadmap 2022 profile, make it mandatory or by default has robust buffer access, or yes. But some people could, for legitimate reasons, say, I don't need a robust buffer access because it makes my application slower, and I don't need this safety feature. So because we think it's a use case that will happen very often, what we can do is say, I want to create my profile and use this flag, which create device robust buffer access, disable, yes, robust buffer access, and create our device, and we will have the robust access disabled. There is also one bit that allows to disable any sort of buffer access, robust buffer access. Okay. So now I want to discuss about a part that I think is very exciting to me, which is the Vulkan profile toolset is fully code generated. So we have this drawing. So basically, we have a pipeline using Python code and C++ code and all that thing in the Vulkan profile repository. And what we can do is just to have a source, vk.xml, another source, which is a set of profile, and out of that, regenerate the profile schema, regenerate the markdown file to compare multiple profile, regenerate the library to include new profiles, new capabilities, new Vulkan capabilities, regenerate the layer to include the new Vulkan capabilities. So for us, it's a huge plus because it makes the entire solution very low maintenance. So you are guaranteed that the solution will always be up to date with the latest Vulkan improvement. You won't fall behind. And that was one of the big issues with DevSim because it was all handwritten and partially supporting Vulkan capabilities. But now the profile layer support all the Vulkan 1.3 capabilities and all the extension, except I think one exception because an extension is not well formed, but that's a detail at this point. So from this design, what we could imagine is that, okay, maybe I can create myself my profile and use my profile and have all these tools working for my use case. So I would like to make an exercise, and this exercise is totally pointless, but at least it gives a point. So what we are going to do is to edit the roadmap 2022 file that will allow us to see exactly what in the file and what it looks like. And we will edit this file to create a new roadmap 2022 profile, but implemented on top of Vulkan 1.2. So for example, the approach, it's Vulkan 1.3 is basically moving some extension to core functionality. So instead of specifying our the roadmap 2022 profile using the core features, the core structures, what we can do, it's using the extensions, and that's what we are going to do. And so we will change the file and we will regenerate the solution, and we will see that the documentation is updated, that the library is updated. And let's go. So I'm going to copy paste that because that will save myself a bit of time. I have my roadmap 2022 file. We are also going to validate our file, checking that it's formed correctly. I hope I'm not going to make too many mistakes. Here I need to copy the contributor section that were missing and the history that was missing. I don't actually remember if they are required, but I think they are. Up. So I think the exercise is pretty pointless because if we look at if we want to implement the full roadmap 2022 profile on top of Vulkan 1.2, we require a Vulkan 1.2.197, which is a few weeks older than 204, header 204. So really, it doesn't really enable a larger set of devices. But I think it's more to see how it works. So we made these changes. So now first, oh yes, so I cheated a bit. So if we look here, we have the way the file is specified in the repository is that the requirements are sorted by Vulkan version plus roadmap 2022 additional feature. So each version of Vulkan have requirements. These requirements are set in the file, but the roadmap 2022 profile added for each version new capabilities. And when I say added to each version, it use a structure that were defined in Vulkan 1.0, for example. So what we can do is just re-implementing this Vulkan 1.3 requirements into Vulkan 1.2 with Vulkan 1.2 extensions. And these two blocks already exist. They are in the file. So we can see if we compare the Vulkan 1.3 requirements, we can see that there is a bunch of new features, there is some properties, and there is no extensions. But we can see that there were a lot going into Vulkan 1.3 because all this extension went to into the core specification. And here there is all the feature enabled. So now that we've done that, we are going to validate that we didn't make a mistake using, I don't know if you know this amazing tool, which is called JSON Schema Validator. I'm going to pass it here. And it tells me the file is valid. I'm using Vulkan 1.3. But maybe what I want to be sure is that my requirements is 1.9.7. So what I'm going to do is to replace this schema by 1.9.7. And now I have plenty of error, and I can inspect the error, and I see, oh yes, this is expected. This structure was added with Vulkan 1.3, and there were this new extension that was also added with Vulkan 1.3. For the fun of it, maybe what I can do it's how do you say, removing these sections just to be green. And this section, and hopefully it should be all fine. And it's all fine. So the file is correct. And why I'm using 1.9.7, I can identify it very easily using the schema from 1.9 header 196, sorry. And it's going to tell me, oh, so in header revision 197, the Khronos group added the KHR dynamic rendering extension and dynamic rendering extension is part of Vulkan 1.3. So we need this extension so we can go further away. Okay, so now what we are going to do, that we know that our file is correct, we are going to recompile the solution. And if everything goes as planned, we should see some things. Oh, actually, I forgot to show you. Too late. I think just for the fun of it, I'm going to rebuild everything again. So if we look at the Vulkan profile.h, we see the define that I show during the presentation. That show, oh, look, there is Android baseline profile. This file is only, this profile is only available if all this extension, if the right version of Vulkan is supported by the Vulkan header on the developer machine. We have the roadmap 2022 profile. And we have our new roadmap 2022 1.2 with all the extension. And we have the desktop portability profile. But what I really, so you see it's green. So maybe you maybe you trust me that this is a real thing. But I think I want to rebuild. I'm just going to remove this just to show that when I rebuild, the header is gone. Actually, we should see, and it's gone already. Yes, that's one of the first steps of the build. So it should be there, but it's not. And I'm going to re-add it because I want to show you the markdown file. So now I'm looking again, and it's back. We have our new file. So now I would like to show you what it does with the comparison table. So if we look up, so I just googled to get any markdown reader, and I'm just going to copy paste the profile file, the profile markdown file. So what we see, we have our new profile that is there, and then we can compare the extensions. So for example, integer.product was a 1.3 core, and now it's an extension that is supported by this profile, and we should have this for every 1.3 feature. So, bon, I guess you get the point that when we want to create our own profile, and we can easily compare with other profile to see what we change. Does it match? And maybe one day we will have an Android baseline 2021 profile, and we will be able to see what was in the previous profile and what's in the new profile. But yes. So I guess this is it for this part. So we are finally, and thank you for staying so long, reaching the end. And I would like to speak about the future possible improvement with the Vulkan profile toolset solution. And for me, the biggest area of work is how to create a profile. Currently, it remains a relatively manual process, and we know that manual processes are not really reliable. There is some way to create some profiles like a GPU info, but it creates device profile. Yes, GPU info.org. We are working on upgrading Vulkan info to export device profile using the profile schema. There is a PR going on, and it's basically ready. So that will be definitely in the next SDK. But really, we should do more. What we really should want from as a Vulkan developer is the capability to take multiple device profile, say, oh, I want my application to work on all these GPU vendor driver, download from gpuinfo.org, combine all this profile to say what are the requirements for the devices I target, but not because we did it manually, but because we figure it out of the file that we downloaded. I guess there is two ways we could combine. There is one way, which is more the platform profile approach that I just said, combining device profile, but there is also maybe a more engine side, which is accumulating requirements. So we should be able to take multiple files and say, I need this requirement plus this feature plus this feature, and that will make my entire engine work, for example. I think it would be super nice if we could have a tool to validate a profile against another. How that will work. So what we will want to do is, for example, to generate a platform profile that will have all the requirements we want, but maybe at some point we would be wondering why my application is working, crashing or not working correctly into a user device. And what we could say is asking the user device to generate a profile file that we could that it will submit to us. Maybe it could be included into a crash log or something like that. And we will be able to look at this profile, compare it with what we say the engine require, and say, look, the game is not working because your GPU doesn't support feature XYZ. So maybe something we need to improve. It's better handling of platform-specific capability. So, for example, surface extension are often instance extensions, but the profile layer doesn't handle instance extension overriding. So it will be nice to be able to say in the profile on Linux, on Mac, on Windows, we want to use this specific extension because these parts are not totally cross-platform. So of course, probably we need to investigate to add more capabilities in the schema to represent more of the Vulkan capabilities. There is also improvement that we think should be done in vk.xml. So vk.xml, if you don't know, and actually I didn't mention before, is really the ground truth of the API, of the Vulkan API. There is the description of all the API code in it. But there is something that I'm really missing for us that will help us to generate our tools. And that's, for example, the default values for the capabilities. It's not part of vk.xml, but it could be very, very convenient if we could generate a profile file with all the minimum requirement of Vulkan, for example. And from that, we could just say, use the minimum requirement, and on top of that, merge it with another profile, and maybe I'm going to manually edit some of the minimum requirements with something else, with more features, more capabilities. And maybe we could consider some better integration of in Vulkan configurator. This is especially to create the profile, but it could be also to generate the markdown, to generate the library, because it's we don't really need to open a Visual Studio solution for that. It's just a Python script. So if we could make the iteration time lower and maybe easier to appropriate the component, that would be nice. So I'm done. Thank you very much for staying. So I see we have one question. And the question is, does this layer effectively obsolete the device simulation layer, or what can the device simulation layer do that the layer, the profile layer cannot? My answer would be yes. I think, I'm not sure what we call it, but we can consider the device simulation layer deprecated. I think there were a notification in the previous SDK to say that it was deprecated. I think it's the profile layer is way more exhaustive in terms of capabilities. The integration is in the validation in the Vulkan configurator is a lot better. There is no, so if we want to, for example, exclude a format, exclude an extension, we can do it without updating the profile file. We can do it directly in the interface of Vulkan configurator. Maybe I can show you very quickly. Yes, so here there is a list of what extension do you want to exclude, it's excluded. And you just need to, you can just launch the application again. And for the application, this extension will not be present. So yes, I think there is no need to use DevSim anymore. Do we have any other question?
There's a new question from Perrin.
Yes. What tool was used to make the markdown table between profile. Yes, but I can send you if we go on Lunargy SDK website, we generate an HTML file for the Markdown, but the tool I use, oops, it was pretty random, I must say. I just Googled it, and it's called Markdown Live Preview, but there is plenty. If you go on Google and you search for Markdown Online, you can, and the output of this one is actually not very nice because there isn't like nice logos. It's just written heavy mark, heavy check mark or some crosses. But yes, but really my favorite tool from this presentation was the JSON schema validator.net. It's really awesome just to be able to go on the web page and check my schema, do some edit and see, oh, I forgot a space. Oh, I forgot a space. Oh, I forgot underscore. So I guess that's it for me. Thank you for attending, and I hope it's for sure the Vulkan Profile Toolset is a new solution. So we are hoping it will be adopted hopefully as quickly as Vulkan Configurator, but even Vulkan Configurator, it took probably a year to be really adopted. So we don't expect an adoption rate very quickly. Plus, there is still some still beta. So, but because it's beta, it would be super nice if we could get feedback and that we can make improvements. That's it. Thank you.
That was an excellent presentation. Thanks, Christophe. And thanks to Jeremy for his earlier presentation. We greatly appreciate your guys' time and effort today. And thank you for attending our webinar. We hope you enjoyed it. As a reminder, a recording of the presentation along with the slides will be available on the Khronos Group website, and a direct link will be sent to you in a follow-up email. Also, there are multiple ways to get involved. For instance, you can join us on Slack and continue discussion and share your feedback with us. As you leave the webinar, please take a moment to fill out the survey that pops up. Your feedback is important to help us improve these presentations. Please let us know if there are other Khronos-related topics that you may be interested in. Thank you for joining us, and have a great day.